Okay, hello everyone. Today we are starting a new unit. We're going to be starting out by talking about special right triangles. So what we've done in the past is we've used Pythagorean theorem to find lots of different right triangles, lots of different angles. Today, what we're going to focus on are two different types of right triangles. And the first one is a 45, 45, 90 triangle. So let me show you what is special about this triangle. So if I was to draw a square, everyone is familiar with the fact that the square has the same sides, right? So let's say this square has 7 as its side. So all of the sides should be 7 units long. I hope you're also familiar with each of these corners should be 90 degrees inside the square. It's a perfect box. So if I was to cut this square in half, just like this, ignore the wavy line. If I was to cut it in half, I hope you can see that this is still 90 degrees. This is still 90 degrees, but we've cut these two corners in half. So now this is 45. This is 45 degrees. This is 45. And this is 45. So if I was just to take one of the triangles, so like this one right here, and draw it down below, I'm going to draw it right here. Again, it's not going to be perfect. Sorry. So here's my 90-degree angle from right here. I've got my 45-degree here. I've got my 45-degree here. I know that the two sides right here are 7 and 7, so I can bring that over. What we want to find is how long the hypotenuse is, this long side right here. Oop. So, how do we do that? What skills do we have to figure out what that side is? I hope that you remember that we did the Pythagorean theorem at some point and you have throughout your math time. So if I know two legs, I know the two sides right here are 7 and 7. I can use the Pythagorean theorem to find the hypotenuse. So let's do that. So remember Pythagorean theorem is a squared plus b squared equals c squared. And we know the two legs are 7 and 7, so I'm going to plug those in. A is 7, B is 7. We want to know the hypotenuse. Hypotenuse is always C. Put a C right here. Okay, 7 squared is 49. 7 squared is also 49. So C squared is 49 plus 49, which is 98. Remember, we want C, not C squared. So we need to get rid of that square. So I'm going to square root it. That's the opposite. And we have C equals the square root of 98. And you're thinking, that doesn't seem very special. Well, you're going to use your skills that we practiced to simplify the radical. So remember, when we're simplifying the radical, we want to factor 98. Preferably, we want to factor it into things that are perfect squares, things we can pull out. So I know, because what we put in, that 98 is the same thing as 49 times 2. If you're concerned about this, you can always multiply it out in your calculator. But I remember that it's 49 times 2. And I know that the square root of 49 is 7. So I'm going to do this. I'm going to separate it here. 49 times the square root of 2 equals 7 times root 2. Okay, this is a rule that is going to hold with all of your 45, 45, 90 triangles. You may see right here 7 is the same thing as the leg. So the main rule that we talk about with 45, 45, 90 triangles is that the hypotenuse is just going to be whatever the legs are times 2. And the legs are always going to be the same. So that's why we have this written here. So they did a generic one here. So if the leg is x, the other leg has to be x, and the hypotenuse is going to be that leg times square root of 2. So let's do a couple of examples down here. Let's do example 1 first. So in example 1, they tell us that the leg is the square root of 8 times the square root of 2. Not super pretty, but we can deal with that. So if one leg is 8 times the square root of 2, the other leg has to be exactly the same. So the other leg, y, is 8 times the square root of 2. We also know that the hypotenuse is the leg times the square root of 2. We have lots of square root of 2's in here. So hypotenuse is x. We know hypotenuse is the leg, which is 8 root 2 times root 2. Okay, and here you're just going to be combining square roots here. So remember, if you've got a square root times a square root, you can put them both under the same square root. I know that 2 times 2 is 4. Do you remember what the square root of 4 is? Hopefully you remember it's 2. And then you have 8 times 2, so your hypotenuse is 16. The legs aren't so nice, but the hypotenuse ended up being nice. So you're just going to follow that same pattern. Let's do it for the next one. And the next one, they give us the hypotenuse, but we have to figure out what the legs are. So remember the leg, so the hypotenuse is the leg times root 2. So I'm going to write that out. Hypotenuse equals leg times root 2. We know the hypotenuse right now. We know the hypotenuse is 6. We want to find the leg. And in this case, we've only got one thing we're looking for. So we just need to get the leg by itself. Think of it just like as a variable. We could have put x in there. That would have been fine. So to get rid of the root 2, I'm going to divide because it was being multiplied. So the leg equals 6 divided by the square root of 2. Okay, something very, very important to remember is we don't like leaving square roots in the bottom. That doesn't work very well for us. So we're going to get that out of the bottom. If you're not quite sure what to do, remember, you can always multiply by 1. So I know that the square root of 2 divided by the square root of 2 is 1. It's one. The same thing over the same thing is still 1. And I know that's going to get rid of the square root. So let's multiply that out. So remember, we multiply tops together, 6 times root 2, and bottoms together. Remember, when you multiply two radicals together, you can have one radical and put them both underneath. So then you have 6 root 2 over the square root of 4. Square root of 4 is nice because that's a normal number. It's 2. So then we get 6 square root of 2 divided by 2. And then very last, we've got 6 over 2, which simplifies down to 3. So 3 root 2 is your leg. And if one leg is 3 root 2, the other leg also has to be 3 root 2. So the important thing to remember here with these 45, 45, 90 triangles is that the legs are both going to be the same. The hypotenuse is going to be the legs times root 2. You can be given a leg, you can be given a hypotenuse, and you should be able to figure out what the other things are. It just takes a little bit of algebra. So let's talk about our next special triangle. The next one we have is called a 30, 60, 90 triangle because the degrees inside the triangle are 30, 60, 90. This triangle is special because it is an equilateral triangle split in half. So if you remember back, I don't know when you learned this, but back in the day, an equilateral triangle means all of the angles are the same. Remember, there's 180 degrees in a triangle, so if they're all the same, that means each angle is 60 degrees. And in an equilateral triangle, all 3 of the sides are the same length too. So let's do, for this example, let's make all the sides 10. So let's say 10 here, 10 here, 10 here. Okay, I'm going to take this equilateral triangle and I am going to split it in half right down the middle. And then I'm going to draw it over to this side over here. So I'm going to draw that triangle right there. So long, got this. Hopefully you can see, so this forms a 90-degree angle. This 60 degrees is going to stay. And then the 60 degrees at the top right here, we split that in half perfectly. So instead of 60 degrees, we're going to have 30 degrees. And that forms our 30, 60, 90 triangle. So let's figure out what the side lengths are then. This hypotenuse, this side right here, is going to stay the same. It's going to be 10. This bottom one, we split directly in half. So this bottom, the short leg over here, is going to be exactly half of the hypotenuse, or half of this length right here. So 5. We just need to figure out what this side is right here. In order to do that, let's do some Pythagorean theorem work again, because we've got two sides, we need to figure out the third. So I'm going to set it up over here. We've got a squared plus b squared equals c squared. A we don't know, b is 5, and c is 10. Okay, so let's solve for a. A squared plus 25 equals 100. So I just did the squares. Now I'm going to subtract 25 from both sides. So 100 minus 25 is 75. I'm just subtracting 25. And then we need the square root of, we need to take the square root of a and 75 so we can figure out what a is by itself. So we get a equals square root of 75. Okay, again, I'm going to simplify it. So let's figure out some things. I know 75 is 25 times 3. So let's do that. Because 25 is a perfect square. So if we're going to separate it out, we've got 25 times the square root of 3. Remember, we can separate them or put them under the square root. It's the same. Square root of 25 is 5, and we're still left with root 3. So this kind of demonstrates what our pattern is here. 5 root 3. So the short leg is x right here, this short leg. The hypotenuse is always going to be 2 times the length of the short leg. So remember over here the short leg was 5 and our hypotenuse is 10. Over here short leg is x, hypotenuse is 2x. And then the long leg, so this is short leg right here, this is long leg. Long leg is going to be x times root 3. So over here we've got 5 times root 3, x times root 3. That is the relationship between the three. Let's use it to solve the next couple problems. So we've got over here, they tell us right here the short leg is 5 root 2. The long leg is y, and the hypotenuse is x. If you're ever not sure which leg is the short leg and which leg is the long leg, you can look at the degrees. So 60 degrees, that's our big angle, right? Besides the 90. So the big angle should always be across from the long side. 30 degrees is our little angle. That should always be across from the short side. Okay, so let's do this here. I think it's going to be easiest to find the hypotenuse first, so let's do that. Remember, the hypotenuse is always the short leg times 2. This is our short leg, so all we're going to do is we're going to do 5 root 2 times 2. The 5 and the 2 you can multiply together, and you get 10 root 2 for your hypotenuse. Okay, then remember again that the long side, or this y, is the same as the short leg times root 3. So let's take our short leg, 5 times root 2, multiply root 3, and that should give us y. Okay, so we're kind of multiplying like things together. So over here I did 5 times 2 because those were both not under the radical. Now here I can do root 2 times root 3 because those are under the radical. So multiplying like things together. So we've got 5 times 2 times 3 under the radical. And that equals 5 times root 6. There's not really any way to simplify root 6. We can split it up into 2 and 3, but those can't factor out. Like you can't do the square root of 2 or square root of 3 to get it out of the radical. So we're going to leave it just like that. So y equals 5 times root 6. Okay, let's do example 4 where we're given, I'm going to separate it a little bit here. We are given the hypotenuse instead of the short side. So remember, the hypotenuse is always twice as big as the leg. So I could take the hypotenuse, 12 root 6. I know that's twice as big as the leg, so let's cut it in half. That should give us the leg. So the leg should be 6 root 6. And you can always double check this. Like, okay, I've got the short leg now. Is that twice, or if I multiply the short leg by 2, does that give me the hypotenuse? Yeah. As long as the proportions stay up, we're good. So short leg I now know is 6 root 6. Then remember the long leg is the short leg times root 3. So I'm going to come over here. I'm going to do 6 root 6 times root 3. And that's y. This is x. Okay, so if I'm going to multiply this out, we've got y equals, and remember, we're going to do multiply radicals together. So 6 times 3. Y equals 6 times square root of 18, because that's 6 times 3. We can simplify 18. So 18 is the same thing as 9 times 2. So y equals 6 times root 9. I'm going to separate these out into their own radicals. Square root of 9 is 3. So we've got 6 times 3 times root 2. So we've now changed root 9 into 3. Now we can do 6 times 3 is 18 times the square root of 2. So your long leg over here is 18 times root 2. Okay, if you ever want to double check this and you are feeling a little bit nervous about the square roots, you can always type it in your calculator. So like I did, 6 times the square root of 6 is 14.7. 18 times the square root of 2 is 25. And I just wanted to make sure that if I did 14 times the square root of 3, I would get 25, and I do. You can kind of double check that way, but your answers should always be in a simplified radical form, and you shouldn't have a radical in the bottom. Don't worry, we'll practice this if it feels unfamiliar. Okay, let's do the last example, and then I'll stop talking your ear off. So in this last example, they give you the long side instead of the short side. This one takes a little bit of thinking. So remember, x is the short side. And the long side, so if we scroll up here, I wrote all over this, huh? So x is the short side. If x is the short side, the long side is x root 3. So short side x, long side is x root 3. Okay, if you look at this, when they give us the long side, they give us 4 root 3. It's written in a really nice form. So can you see that the number in front of root 3 should be x? So that means the short side is just 4. And if you wanted to double check it, you would say, okay, short side, I'm going to multiply by square root of 3, and that should give me my long side. and you get 4 root 3. So you kind of just have to look at the proportions here. Here is really nice because it's written out exactly with the root 3. So you can just tell that x is the thing in front of it. So short side is 4. And remember, hypotenuse is just twice as big as the short side. So the hypotenuse is 8. We've got nice numbers on this one. Okay, I hope that was helpful. Good luck with your homework.